everyone, this video is going to cover factoring a trinomial in the form ax squared plus bx plus c equals 0, where the a term is not equal to 1. Okay, we spent a lot of time on trinomials that begin with 1. Let's move on to something a little bit more difficult. So our first example is going to look like this. We've got 2x squared plus 9x equals 18. Okay. You can see the first problem is we don't have 0 on one side. So let's get all the terms on one side, 0 on the other, and make sure that we're going down in order of exponent. So we start with the square term, then we've got x to the first, and then we've got our constant, which is x to the 0, if you will. Okay. I'm going to teach you a method where we go ahead and we set up two binomials. Okay. And the problem with this is we don't know if it's 2x and x or x and 2x. Okay. It will matter which two numbers we put left and right into these binomials, where it used to not when we just had plain old x squared. Okay, so here's my method for taking care of that. I'm going to set up two binomials, and I'm actually only going to put a plain old 1x in the beginning of both of them. Okay, now that's not really what it should, because x times x should only give us back 1x squared, not 2x squared. But the way that I take care of that is by putting a 2 in the denominator of the two constants that are eventually going to go in these blank spaces. Now, the way that I come up with those two numbers is I make an x like this. Many of you have seen this before. And in the top, I put the a term times the c term, which in this case is 2 times negative 18, or negative 36. Down here, we put the b term, which is 9. Okay. And in the left and right spaces that are blank right now, we need two factors of negative 36 that add to 9. Two factors of negative 36 that add to 9. Let's see. We've got 9 and 4. Can I get 9 out of that? Well, no. We've got 12 and 3. Can I get 9 out of that? Yes, I can. If I make the 12 positive and the 3 negative, okay, that would multiply to negative 36 and add to 9. Alright, so we've got our 12 and negative 3. So we're going to add the 12 and subtract the 3. And you can see it would not matter which order you do that in. You could put the 12 in the right binomial and the negative 3 in the left binomial, and it wouldn't change anything. Alright, next step. We're going to reduce if possible, and 12 over 2 reduces to 6. Okay. 3 halves does not reduce. We can just leave it like that. Okay. And of course, we're setting these equal to 0, so if you set x plus 6 equal to 0, you get x equals negative 6, and if you set x minus 3 halves equal to 0, you get x equals positive 3 halves. Okay. Just a small note, if you're just told to factor and not solve, what you can do is change x minus 3 halves. You can put the 2 in front, and you'd have 2x minus 3. Okay. And of course, if you set 2x minus 3 equal to 0, in the end, you'd get 3 halves, just like over here. If you're just told to factor, you might want to write it this way. If you're told to solve and get the two solutions to the quadratic, then this simpler method is the way to go. Alright, let's do that again so that we can make sure that we've got that pattern down. Okay, so let's try 6x squared equals 5x plus 6. 6x squared equals 5x plus 6. Alright, first step, we want to get all the terms on one side and 0 on the other. Okay. Second step, we're going to make two blank, two open sets of parentheses here with a plain old x in the beginning of both of them. And I'm going to take this a term of 6 and put it as the denominator of the two factors that I need to figure out over here. Okay. In here, we need the a term times the c term. That would be 6 times negative 6, which is negative 36 again. Alright, and then I need a b term of 5 here. B term is negative 5. Alright, I need two factors of negative 36 that add to negative 5. Okay, I'm going to try that 9 and 4 again, and this time it's going to work. To add to negative 5, we need the 9 to be negative and the 4 to be positive. Okay, and I'm going to subtract 9 and add 4, and again, it doesn't matter what order. Okay, next thing that you want to do is reduce. So that's going to be 3 over 2 and 2 over 3. Okay. And set those two equal to 0, you get a positive 3 halves and a negative 2/3. Okay. If you were factoring using another method, you might end up taking these 2 and the 3 here and putting them in front, so your factors could be said to be 2x minus 3 and 3x plus 2. But again, if all you need is your solutions, you're just going to go straight here. All right, hope this helps.